question, and we are going to see today Leetcode question, and we'll see the today question. Okay, so today we have given the question that we have is 20 of the Leetcode question, that is a valid parenthesis. I think you already have heard these questions, right? This question is mostly used to ask in the college time when you were on you were using Facebook or right, some other platform where you see this question has been asked in Amazon, Facebook, like that. Similarly, this question is similar to that question, only the valid parenthesis, right? And computer science already knows that the parenthesis, right? So sometimes how your compiler gives you the error that gives that's come through this program only. So you can say, if you want to implement you can say the program that is similar to compiler, right? A small compiler. This is the very good example, and you can implement a small compiler too. Okay, so question is saying string s containing characters like this, opening braces, ending braces, opening braces, ending braces, like this we have given, right? Now we have to determine if the input string is valid or not. So how we can say that input is valid, right? So if the first open bracket must be closed by same type of bracket, like this should be closed by this only, this should be closed by this only, and this should be closed by this. So like this it is saying. Now the second point is saying open brackets must be closed in the correct order, right? So if the sentence is saying that, like if if we have some string, right? In string, if the starting braces are started, right, so you cannot close like this only, right? So the closing braces for this should be this, right? And if you are writing this, right, so then this part is valid, right? And you are closing again, so there should be one starting braces of this one, right? So order should be must, correct order should be there, right? Now third is saying that every closed bracket has a corresponding open bracket of the same type, right? So every bracket has a corresponding open bracket of same type, right? You got it, right? Now let's understand example one, in which it is given these starting braces, and we have for these starting braces the correct order is what, this one, right? So it should be there, right? So every closed bracket has a corresponding open bracket. So this closed bracket have open bracket. All these three are matching, right? First it is saying open bracket must be closed by the same type bracket, and that is here, right? It is saying the open bracket must be closed by the correct order. Yeah, this is the correct order. And then it's saying that closing braces should have the open bracket, same open bracket type, right? And it is there, so that's why it is coming true. Next example, it is saying that we have given you can say s equal to what, these things we have given, starting braces, closing braces, starting braces, closing braces, curly braces, starting and curly braces, this one. So this is starting here, this is closing here, this is starting here, this is closing here, this is starting here, this is closing here, right? So all three rules it is following, so it is also valid, right? Let's come to another example that we have given, like this one, right? So I think we have already seen this one. Now understand, as the starting braces is the opening braces, now we are using the closing braces for the ending braces, right? And this example is not valid because for this one, for this opening braces, ending braces would be what, this one, and for this one the starting braces would be this one. So both rules are not getting true, right? That's why we can say this is returning false, and this is also true, right? Coming back to the constant, length should be greater than or equal to 1, and 10 to the power 4 consists of parenthesis, right? S is consist of parenthesis, and like this we have only. Okay, now think about the question, how many questions you can solve after this solving the question. You can solve by using the generated parenthesis. The links are there in the problem, right? You can use the links, and you can get the other questions, right? So after doing the hands-ons of this problem, you can do this problem. If you find any issue and you want the solution for those questions, please let me know or ping me in the comment box, right? Now coming back to the question has been asked in Amazon interview, right? And all top companies we have asked: Amazon, Google, Facebook, Apple, Adobe, right? Those companies have already asked these questions. Okay, so this question is very important, and I also used to heard mostly Amazon ask this question, so that you can see 11 times he has asked the question. Now coming back to here, right, what we have to do now, first of all we have to imagine you are writing a small compiler, suppose, right? So for your like for your college project, right? So one of the task or say subtask for the compiler would be to detect if the parentheses are in place or not, right? So you can take like that, or you can creating a new project, right? So if you are creating a small you can say compiler program, right? So in that the algorithm we will look at at this time, right, can be then used to process all the parentheses in the program. Your compiler is compiling and checking if all the parentheses are in place. This makes checking if the given parenthesis of a parenthesis is valid or not, right? So it is important program, right? The expression that we will deal with this problem can consist of three different type of parentheses: the starting braces, ending braces, and those that we have already seen, right? Like this, either this, or either this, right? So three things we have. So all three things we will use either of this one, right? And before looking at how can we check if a given parenthesis consist of these parentheses is valid or not. So let us look at the similar version of the problem that consists of just one type of parenthesis, so that the expression we can encounter in this simplified version of the problem are, you can use what, let's suppose we will take in the starting brace we will use like this, then this, then this, then this. You can use, right, like this. You can also use like this, right, like this you can use, right? Or you can, what you can do, if you write like 1 2 3 4 5 and only 2 you are closing, so these are valid, right? These are valid, but this is invalid, correct? If you want to write like this, this is starting braces and ending braces, starting braces, ending braces, like this, and you can do starting braces, ending braces, starting braces, ending braces. So this is also valid, right? So what we have to do, actually, we will simply we will follow these things, right? We will follow these rules and we'll try to implement this one. So now understand, if we have this example, okay? So in this example, what we will do, we will simply doing the simple algorithm. We will deal with this problem. Actually, we will process the expression one bracket at a time, starting from the left, right? So we'll take left as a variable and we'll start. So first, let's suppose first we have at the starting braces, right? We are at here, okay? We are at here, and so the left is what, 1. Now we will move to here. Now 2 left is coming. First left was here, second left is here, so now left is 2, okay? So next we will go here. So this left is all, this left has been completed by this one, right? This is completed. So now we will update our left to 1 because only 1 is left, right? Next we will go to here. Now left, this is also left, so we will increment our left. Next we will move here. Now we will say left is 3, right? Now this left is completed by here, so now we will reduce one left, and now left is here. So it was now where is the left? First it was here, right? Then we have came here, then this part is now completed, so we will reduce here 3 2, it became 2. Now we will go to the next. Now it is what, 3, so now it is completed, so we will reduce left. We will go to the next. Left increases, left reduces, left reduces, left reduces. So if the left is look like this one, right, means this is a valid expression, right? I think you got me. If you have any doubt here, you can ping me in the comment box. Now coming back to the approach, so we can use the stack, right, to implement this problem, right? So actually our problem, we encounter, we don't really know if there is a corresponding opening braces available or not. So that's why we are using that one, right? Left things, right? We will each time we will update, right? So the closest unmatched opening braces available in the curly braces, not the square bracket. These things we will not understand. We will just follow all the braces, right? And we'll do that. Okay, now coming back to the our approaches, what we will do, we will have opening braces, right, and ending braces. Means we are understanding about the expressions, right? So valid expressions, sub expressions, right? So each time we have to understand the sub expressions, right, and ending braces. Why? Because there will be multiple types of braces, right? It will can be the smallest bracket, middle bracket on, and top bracket, right? We have to do. So, and the interesting property about a valid parenthesis expression is that sub expression of a valid expression should be a valid expression, not every sub expression, right? Like we have here. So also, if you look at this picture, right, this what you will see, we have a valid sub expression, right? How? There is combinations of the bigger one and the smaller one, right? This is a sub valid expression in which only a smaller is coming, right? Here, from here to here, from here to here, right? And if you understand the whole, right, this is the expression of the sub expressions, right? So what we have to do, the colored code cells mark the opening and closing braces of the parentheses here, and the entire expression is valid, but sub portion of it also valid in the in themselves, you can say. So this lends a sort of a recursive problem structure of the problem, right? While for example, let's understand, consider the expression enclosed within the two green parentheses. First we have started from here, and second we have started here, right? So within that you can see this is a valid sub expression. Why? Because it started and it's ending, both we have here, right? So what we have to understand, right, the expression enclosed within the two green parentheses in this diagram, right, you can see in the figure, the opening braces at 1, at what, 1, and ending at 6. You can count here, right, from 0, 1, 2, 3, 4, 5, 6, right? Between these, the corresponding closing braces at 6, right? So whatever, if whenever we encounter a matching pair of the parentheses in the expression, we simply remove it from the expression, right? And we'll do let us look here. Okay, so first of all, if we have given like this, right, we have given like this. So let's look at this idea, right, and where we will remove the smaller expression, expressions one at a time from the overall expression. And since this is the valid expression, we would be left with an empty string at the end, right? So what we'll do, we'll check this one and we'll say we'll remove this. Now we'll check this one and we'll remove this one. Now again we'll check this one and we'll remove this one. So finally it will left like this, right? Now what we'll understand here is we'll see the stack data structure. That is our approach, right? A stack data structure we'll see, and we'll see the implementation of this one, right? So the stack data structure, DS, we can say stack data structure can come in handy here in representing this recursive structure of the problem, and we can't really process this from inside outside, right? Inside out, we can say, because we don't have an idea about the overall structure. But the stack can help us to process this recursively from outside in inward, right? Let us understand this approach or algorithm using the data structure, and we'll try to implement the here. So first of all, what we will do, we will initialize a stack like this, and we'll now process each bracket of this the given expression, right, into here at a time, and we'll encounter an opening braces, we simply push into the stack, and this means we will process it later. So what we'll do, simply we'll move on to the sub expression ahead. If we encounter a closing braces, then we can check the element on the top of the stack, and if the element at the top of the stack is opening braces of the same type, then we will pop it off the stack and will continue processing, else this implies an expression, right? So at the end, if we left the stack still simply elements we have, then simply it is an invalid, because if there is valid, this stack should not contain anything, right? So let's continue and understand this one. So first it is the starting braces is coming, right, this one, so we'll put into the stack, right? Now what will go, we'll move to the another one, we'll put onto the stack. Now we'll come to next one, similarly we'll process like this. So when we reach here, right, so this is the closing braces. So what we'll do, we'll remove this you can say from the stack, right? Second time we will also see this one, right? So actually this part is removed actually, as you can see. Okay, now coming back to here, we'll push here, right? Now we will see this one, right? So now previously we have removed this one, now we will remove this one, okay, because this is the closing braces we got from here. Now coming back to here, this is a closing braces. Then what we will do, from here to here we will removing actually, right? Means these two we have already removed, now we are removing this one. Now this is a closing braces, right? So what it means, we have already removed from here to here just now we are removing from here to here. Okay, now there is this braces is left, right? Now what we will do, we'll put into this, we'll remove from the stack, then we will get this one, then we will remove this one. So like this we will continue our approach, right? And we'll try to implement in the stack way, right? Let's understand the implementation. I think you already got, right? So that what will happen, first of all we'll take a has map, right? The character has map, and we'll take a mapping that I will give the name of character mapping, right? And what will happen, actually mapping we are putting like this. Okay, we'll take a map like this, and we'll take the ending braces, closing braces, starting braces, the ending braces, starting braces, right? Like this we'll put into the stack, so that we have our mapping, and this is nothing but our this mapping. Okay, so if this mapping is ready, we have already initialized. So what will, after the initializing this one, you have the you can say mapping here, right? Now coming back to the valid, right, we will put a string into this function, right? So a string s, what we will do, first of all we'll get a stack. This is your stack, as you have already seen the previously example. So this is your stack. Okay, on this stack what will happen, we'll go to the string all the character from index 0 to its last length. So character at I will get character C. Each time we will check on the mapping. If this is this character is already on the mapping, right, means these are the closing braces, this is a closing braces, right? If this is closing braces, right, if the character is a closing braces, then what we'll do, we'll get the top of the stack. If the stack is empty, right, we'll set a dummy value, this one. So we'll do top element equal to a stack.empty. If this is empty, we'll put this one, otherwise we will pop. Means if this any of these closing braces is there, right, and if a stack is not empty, then we will remove. If a stack is empty, we will put a has, right? Now what we'll do, actually let's suppose initially you got a closing braces in the in the expression, and all element are there, right? So we'll not, because see we cannot remove this one because this is a closing braces, right? And if this is a closing braces, how we will continue this one, right? So to do that, what we will do, we'll push a has actually, right? The top element actually is has, not the any element, because if we don't have the element on the stack, we'll get some null pointer exception, right? Now coming back to the next, if we'll do, if the mapping for the bracket doesn't match the stack top element, right, in that case what we will do, we will return false, and we are doing here. Okay, now understand else condition. If this is an opening braces, then only we will push onto the stack, and if not, this is opening braces, means you already know this is a closing braces, in that time we will remove from the top. Okay, and if this is empty, then we'll do push a has, or any other simple you will push. And if it is stack is empty, if it is stack is still contain element, we'll say this is invalid string. So stack empty should say this is valid or not, right? So if it is containing like a star or something new that we have put has, right, in that case also it is invalid. Okay, so if there should be no value into the stack, in that case only you will get what, you will get valid expression, right? I think you got me. If you any doubt, you can ping me in the comment box. Now coming back to you can say complexity. Time complexity will remain O of n, and space is also. Why? Because see, we are moving to all the character, right? As you can see here, we are going to all the character, as well as we also pushing all the characters onto the stack, right? And that's why we have taken here a stack. Sorry, yeah, you have also taken the stack. Okay, so first we have taken the character hash map, right? Then we have put all these three, but we have also taken a stack, and all the element from 0 to n-1 will take, right? So O of n is the time complexity and a space complexity also. Okay, so thank you guys. If you like this video, please hit subscribe so that you will get more videos like this. Thank you for watching this video.